Okay, so in this question, we've been presented with a hydrocarbon, and we've been told that the molar mass of that hydrocarbon is 70 grams per mole, and we've been told that its empirical formula is CH2, and we've been asked to work out what the molecular formula is. So how would we go about this? Well, we know that the empirical formula is effectively the simplest, or albeit the smallest, whole number ratio of the atoms or of the elements contained in the particular compound. The thing is, for molecular formula, well, in order to effectively get to what the molecular formula is, we would need to first work out, or at least I'm going to approach this by first working out what the molar mass of the empirical formula is. And we know our formula contains hydrogen and it contains carbon, of course, hydrocarbon, right? So the first thing I'm going to do is I'm going to need to get the molar masses, or albeit the relative atomic masses, of the hydrogen and the carbon. And so I'm going to get that from the periodic table, although given how common carbon and hydrogen are, you may well already know what the molar masses of these are, or albeit know what the relative atomic masses and hence the molar masses are. So in this case, I'm going to go, okay, so for carbon, we've got 12 here, as you can see. So we know from that for the MR, right, so that's the relative atomic mass, but the MR is more or less the same thing. The molar mass of carbon is going to be 12, right? 12.0 grams per mole, right? And for hydrogen, we can see it's going to be 1, right? So that's going to be MR of hydrogen is going to be 1.0 grams per mole, right? Now, as I said, you may well already know that, and but I'm just making sure that my actual working is quite clear, and in written form, basically. Okay, so what am I going to do with that information? Well, I'm going to use it to work out the molar mass of the empirical formula. So as you can see, I'm going to set up an equation here. So, or should I say a calculation? But anyway, for carbon, we're going to have 12.0, right? So I just wrote 12, and there's only one. It occurs once in the empirical formula. So that's going to just be 12 times 1. And we're going to add this to hydrogen occurs twice, right? So we're going to have 1, as you see, from 1.0 multiplied, and it's because it's CH2, H2, so therefore the 1's going to be multiplied by 2, right? And so I'd invite you to have a go and work out what that's going to be, right? And so if you did that, what you should find is that you get 14, right? So effectively, the MR of CH2 is equal to 14 grams per mole. Okay, so what do we need to do with that? Well, we've been told in our question the molar mass of the molecule that we're looking for is 70 grams per mole. Of course, this 14 in this case is not 70, right? And so what we need to do is we need to find a multiplier. What do we need to multiply 14 by to get to 70? And the straightforward way to work this out is simply to divide 70 by 14, right? So that's what we're going to do. So 70, not 17. 70 divided by 14. All right, and that's going to give us, well, you can kind of, based on visual inspection, you can kind of infer what this is actually going to be, but you can feel free to work that out on your calculator too as well if you're not sure. But if you do work that out, you're going to find that that's going to give you 5, right? So this 5 is going to be our multiplier. So the multiplier is going to be 5x, right? And so what do we need to do? Effectively, we use that multiplier and we apply it to each of the constituent atoms that appeared in the empirical formula. And effectively, by doing that, we scale up the empirical formula to get to the molecular formula. So in this case, for carbon, effectively what you could say, what the coefficient of the carbon was effectively 1, right? So it occurred once, and so here what we do is we do 1 multiplied by 5, and that will give us 5. So we know based on that later on we're going to have C5 in the molecular formula. Now for hydrogen, right, as we know, we've got CH2, right? So in the case of CH2, the coefficient specifically for hydrogen is going to be 2, right? And so we've got 2 times the multiplier, which is 5 again, and that's going to give us 10, right? And based on that, we can say, okay, so for the molecular formula, we're going to have H10, okay? Okay, so given these numbers, we can now put this together to form the molecular formula that we've calculated. And based on this, we can say, well, the molecular formula is going to be C5H10, okay? So in this particular question, where it's asking us what's the molecular formula of this hydrocarbon, what we've been able to work out is that it's going to be C5H10, all right?